Now, this is the third video for our chapter 12, talking about the logarithmic function. Now, let me review the exponential function first. So earlier we talked about the exponential function. Exponential functions. And we learn how to graph the exponential function. So first we find the key point 0, 1, and then we find the asymptote. And then we memorize the parent graph, which shows the graph here. And you see the yellow color graph is y equals to 3 to the x. This is the exponential function. Now, if I ask you to find the inverse function, find the inverse function of exponential function. Now, if you remember, we have another video for inverse function. There's also chapter 12 video talking about the inverse function. If we have a graph, we can easily graph the inverse function. So if we already have the exponential function, how we graph the inverse function? So first, you draw a symmetrical line. Y equals to x. This is the symmetrical line. So y equals to x. Y is important because when you exchange x and y, x-axis become y-axis, and the y-axis goes to x-axis. So it's kind of, if you fold your paper along y equals to x, then you have the inverse function, because the definition of the inverse function means input become output. So input, output, and the output become input. That's how you find the inverse function. So graph inverse function very easy. So let me first graph it for you. 0, 1 become 1, 0. So you have 1, 0 here. Let me rewrite to looks better. You have 1, 0. And then the asymptote become from the x-axis asymptote become y-axis asymptote. So this is the asymptote x equals to 0. And then when this curve, the yellow graph, goes to left-hand side of the 0, 1, then same thing, left-hand side means goes to the negative side. Okay. So we goes to the negative side here. So the graph, let me use blue color. So graph go to negative side and follow the asymptote. Okay. And then in order to easily graph, we can find out that there's one more point on the exponential function. You have 1, 3. So in other words, you have 3, 1. 3, 1 here. Wow. All the points are squeezed together. 3, 1. So this is 1, 0. And then 3, 1. So we connect as a curve and keep going. So roughly, we have the inverse of y equals to 3 to the x. So graph is not hard. You may even remember the inverse function of this graph as a parent graph. So again, graph is not a problem. The problem is how you denote the inverse function. You say the inverse function equals to y equals to what? And again, in order to solve for the inverse function, first step we exchange x and y. So you have x equals to 3 to the y, and the second step we solve for y. How we solve for y? So y is the exponent. Exponent y equals to something to do with base 3. That's all you know, right? So whenever you have base 3 for sure, and the x and y input the output will so x is input, right? Input x and the output y will have some relationship. But the only thing we are sure is base 3. The other things just follow the exponential function rule. So how we denote the notation? That's what we had to learn. And once we learn a new notation, then we need to learn addition, subtraction, division, multiplication, all the possible operations for this new notation. Now, before I introduce the new notation, I want to mention something we learned before. So say before we had to solve for x squared equals to 1, x squared equals to 2. If you review the video for chapter 10, we talk about that. When you are able to guess the answer, we can guess the answer, right? But whenever there's a 2 and if you, without a calculator, we need to find a new notation called square root. And we carry this important number 2. So x is positive square root of 3. I call this notation is a cheating. Why is a cheating? Didn't really solve for anything, but just give you a new notation with 3 and with the notation of the inverse function called square root. So same thing here. When you want to solve for the y, this y is the exponent, and without calculator you have no way to approach the solution. So the mathematician create, I say, a cheating notation. Didn't really tell you the answer, but this notation may carry all the important notations. Information. Carry important information. Now, unlike the square root, this symbol is so easy, right? But this time, in order to solve for y, this new notation is very complicated. Let me erase the extra note first. Let me erase this. This just for extra information, telling you the new notation basically we say is a cheating note, but it do carry the important information. So it carry the important information from our new notation. Okay, so this we want to solve for the exponent y. This exponent equal to something. Now, before I give you the new notation, I want you to understand this new notation, the output is the exponent. This is very important. Okay, so and this exponent, what's the base? 3. So the new notation will be L O G. Okay, why we don't want to have L? That's better, right? But that's not my choice. Okay, L O G. And what's the base? Okay, before we say the base, we know what's the base. But where you put the input, you need to have a parenthesis for your input, right? Now, this notation means the inverse function for when you exchange x and y, but depends on what's the base. Sometimes you have to solve for base 2, sometimes base 5, right? So this base will be right down here. Depends on what's your base. So formally, I will write down the base as b. So this is formally introduced for the logarithmic function. Log base b, it means the base is b, exponent is y, and equals to x. And if you exchange x and y, you go back to the exponential function. And this one also looks like an exponential function, but because you exchange x and y, then it's harder to say it's the exponential function. We say this, you need to solve for logarithmic function. Logarithmic function. Okay. Now let me go back to the. So this example is for when you have base greater than 1. When you have base between 1 and 0, then the graph will be different. But don't worry, we are going to do it later. Okay. Now we go back to say if we learn a new notation. I said that before you learn how to graph or anything, you need to learn the addition, subtraction, multiplication for all the operations. Okay. So logarithmic function. So we say the inverse. Let me formally write down the definition. Okay. The inverse function of exponential function. Let me change color. So I don't need to write them because it's this one. It's logarithmic function, and this logarithmic function, same thing, the base. So it's here, is, okay. Now, so when you have logarithmic function, basically, number one, you exchange x and y. So you have to have x equals to b to the y, and you have b, same information, and then number two, solve for y. So solve for y exponent. Y is the exponent. With base b. So solve for exponents y with base b. So we have a new notation. Okay, so this is the new notation. Y equals to log base b input x. That's the new notation. Okay, so by doing this, we have some formula. Those formulas, if you already understand the concept, then it's easy for you to understand. So this is input x, right? So how you understand the new notation? You have x, first one, x equals to b to the 0. And what's the exponent? So when you have log base b, basically it's asking you what's the y exponent. What's the exponent of x with base b? That's what it means. Obviously, what's the exponent? 0. So y is 0. So this one answer is 0. Okay? So kinda you can cancel out this. Do you see that? Okay, next question. The x is x equals to b1. And you try to find the exponent. So what's the exponent? 1. When x converted to become base b, then what's the exponent? So this is exponent. This is the base. So answer is 1. Then same idea, base b, log base b, you can cancel out. So pretty much you can guess here, here. Answer is n. Do you agree? Let me see. So input x is b to the m. And what's the exponent? M. So exponent. Input means x. Okay. Now, next formula, can you, because this base b, this base a is different, so you cannot cancel out. Okay, you cannot. But you can bring this m outside to multiply. So you can bring this m to the front. Let me erase the mark here. Okay, erase the mark to make it look better. Okay, you can bring the m to the outside and then write down the rest, which is log base b input a. Now, why is that? In our homework section, I show you the detail reason. But right now, today, I said that this video mostly for learn how to graph, and then we want to learn how to write down the domain and the range. So for the calculation or the proof for the formula, you can find it on our homework PDF file document. Okay. So this is very important formula. Next, when you have base b, when I try to type the formula, it's not easy to type correctly. So let me do this way. And this b is the base, and the exponent is very big. Okay, so let me try. This is base b. Wow. And what's the exponent? The exponent is the whole thing. This whole thing is the exponent. Okay. Now, when you have base b and the log b, do you see log b here? Can we cancel out? Can I just cancel out this one with this one? Yes. So the answer become A. Okay, this answer is A. So in other words, when you have base b with log b, you can cancel out. If you change the order, you have log base b, and the input you have b to the some degree, then same thing you can cancel out. And I showed the proof on my PDF file. You can find it. So I don't want to waste the time to explain the writing. Okay. Now, finally, there's another important formula here. Is the last one. That's very important. Same thing, I'm not going to prove this formula here, but it's very easy to use. And it's very important I mention this formula in the video right now. Okay, so if I ask you to estimate or evaluate the approximate answer like log 2, 3, wow, it's hard. The number is so easy, but it's very hard to find the approximate number. If I say log base 2 and 2, then you say, okay, the exponent is 1, so cancel out is 1 is accurate answer. You can do it. But if 3 become hard. If you try to use a calculator, I think if you have to the TI-84 calculator, you cannot directly find the answer. Probably if you have TI-86, you can find a command a key on your calculator. You can input this number and the input. So you can input the base and the input this 3, I say is amount. Okay, you can input. And then you can directly find the answer. They will probably give you 1 point something, 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 something. Approximate decimal number. But up to TI-84, you cannot. But anyway, we are going to give you a formula. No matter what type of the base, you can always use TI-84 to find your answer. So what you can find, the tool what you can find from TI-84, there are only 2 types of the base. Let me erase this, erase this. So when you have base 10, okay, you can use a calculator. But on the calculator, you won't find log base 10. You only find log base, a log without any base. It means log 10. We say this is a common base. 10 is common base. So without write, when you don't see any number for the base, means base 10. It's same as when you have square root, you don't see any number 2 there, but it means 2. Okay. Now another important base, which is base E. What's base E? I may create another video, but before I create a new video, you can find all the important concept and the proof and all material inside my PDF file document. Okay, so for now, I will simply tell you there's another base called base E. E is a number about 2 point something, 2.78, I don't remember, around. That's why this number so important. Is irrational number. It's very similar to like a pi equals to 3.14152.159. I forgot. Okay, so it's a irrational number, means the digit after the decimal point is no pattern. No pattern at all. I didn't spell correctly. Okay, anyway. So this E, why they choose this E? Again, I say I explain in my PDF file. And if you have base E, we call it a natural base. Natural base. So I use log base E and the input. But again, you won't see log base E in your calculator. You are going to see ln or ln. Okay, I think it's better I put the print out ln and the input x. So if you use TI-84, then you need to convert all the base to either base 10 or base E. And this is the formula you can use. Pretend if you want to find log base 2 input 3, then you can choose ln 3 and the ln 2. Okay. Now the input, this input we call it amount. The b we call it base, and the 1 is exponent. The output y is the exponent. So that's the name you have to learn. But again, this video we don't talk about how to do the calculation with the new notation. Here we want to concentrate on how to graph and how to find the domain and the range. So same thing, you need to find the key point. So key point before is 0, 1, and right now is 1, 0. Asymptote before is y equals to 0. Right now, exchange x and y, you have x equals to 0 for the parent function. Now, if not the parent function, you need to shift, do the transformation. So again, that's chapter 11. You can learn this skill. Okay. So roughly, I show you the idea of the graph when b base is greater than 1. So this base greater than 1, that's the inverse function called logarithmic function. Okay, and this yellow color is the exponential function. So after we understand the concept, we can quickly go to the rest of the page, and when base is greater than 1, is same thing here. Okay, I'm not going to do it again. So you need to have the parent function, and then you graph. You can use you can memorize if you want. You can memorize 1, 0 and go up and down. You memorize the parent function graph of logarithm. Okay, so you have 1, 0 and 1 up, 1 down, and the asymptote is y equals to 0. Okay, now next, when we go to the base, this is base greater than 1. How about when base between 1 and 0? How we graph? So remember, the exponential graph for y equals to 3 to the x, and then we try to find y equal to 1/3. Well, this color not seeing well, so let me erase. Let me find a better color so you can see better. This y equals to 1/3 x basically is y equal to 3 negative 1 x is same as negative x. So we just exchange x and y. When you exchange, not exchange x and y, sorry. You have positive x become negative x. So just exchange left and right. Exchange left and right. So you go to here and go up here. Okay, I didn't graph very well, but just and the same asymptote. When you exchange positive x to the negative x, the x-axis is still the same, right? Okay, but this is not what our answer. This is exponential function. We need to graph the logarithmic function. So let me erase the yellow color. erase the yellow color. Okay, and then let me make this graph a little better. Okay, so say this is our logarithmic function when the base is between 0 and 1. And then let me draw the symmetrical line. Y equals to x. Okay, y equals to x. So you want to have, let me have red color. 0, 1 become 1, 0. And the asymptote y equal to 0 become x equal to 0. Okay. Now, from here, how you graph? If you want, you can choose one more point to help. Okay. But basically, if you fold your paper along here, you can see that your graph is on the negative side of the asymptote. And after you exchange xy, your graph will be on the negative side of the new asymptote. So will be the old asymptote will be here. Yeah. Yes, it's here. Right. And this part will be goes to there. Did I do right? Let me double check. Is that right? And this is a common point, right? When you exchange x, y, any graph when it goes through x equals y, this is x equals to y. You can say xx, or you say yy. This is same x and y. So when you exchange x and y, this point is still there. So this one goes to here, this one goes to there. Right? Okay, let me double check. You have 1/3. You have x1 is 1/3. When x is 1, you have 1/3. 1/3. And the negative 1, you have 3. Negative 1. When x negative 1, that graph right? Negative 1, you have 3. Yeah. So you have negative 1, 3. So 3, negative 1. 3, negative 1. Yeah. 3, negative 1. When you have 1, you have 1/3. You have 1/3 here. 1, you have 1/3. So it's 1/3 is not going through this way. The graph not very accurate. Okay, 1, you have 1/3 here. So graph goes to here. Okay. And the red color should 1 goes to 1/3. So 1/3 goes to 1. 1/3 goes to 1 here. Oh, change color. 1/3 goes to 1. 1/3, 1. And here you have 1/3. Okay. So we connect the graph this way. So this is our graph. Okay. And you have something. Maybe here we don't know what's the number, but okay. So let me show. Okay. Okay. So let me erase those complicated numbers. Here. So this will be the graph. I didn't graph very well. So this is the logarithmic function when base is 1/3. Input x, output is y. So it means when the base is between 0 and 1, if you want to memorize as the parent's graph, you can do so. Okay? So this is this one, and then we go to more complicated one. So again, when you have parent's function for b greater than 1, it's this, right? So you can do that. So let me use your asymptote right now is x equals to 0. X equals to 0, and the important number is 1, 0. And we have 1 up, 1 down. We memorize. Okay, double check for this one. Okay. Okay, here. Now, when you have y equals to base to the x, and remember we have minus h and plus k. So first we want to make sure s minus h is 0, right? But right now this s minus h and this minus is different. This is x, h, this was y before. So when x minus h equal to 0, the base 0 is 1. So actually the input was 1 y value before. So when you have logarithmic function, what should you do? How you find h? You need to have x minus h make it equals to 1, and then you solve for h. Okay? So again, when you have a exponential function, you need to solve for x minus h equals to 0 and y equals to 1. But right now, and the b to the exponent equals to 1. And right now, you have to make it this one, x minus h equals to 1. So you have log base and the input 1. It will be 0. Okay, so y will be 0 plus k, which is k. Now, h is then x equals to 1 plus h. So kind of before the key point is h 1 plus k, and right now the key point is 1 plus h k. You exchange x and y. So the formula need to exchange x and y. So your new asymptote, x minus 5 equals to 1, x equals to 6. And when this is 1, log 3, 1 plus 7 is y equals to 0 plus 7 is k. So the new important number, new key point will be 6, 7. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So you have 6, 7 here. And what's your new asymptote? Because you shift your x to right hand side, right? From 1 to 6 means you shift 5 steps. And this 5 is this number. Okay? So when h equals to 5, remember last time we had the asymptote y equal to k, and right now you exchange x, y, so become y equals x equal to h. You exchange x and y. So you have asymptote 5 here. X equals to 5. You have x equals to 5. And then 1 up, 1 down. That's how you graph. This is y equal to log base 3 input x minus 5 and then plus 7. Okay? So in general, let me repeat the formula for you. So say we have, if you have, number 1, if you have y equals to base x minus h plus k, then your key point is h 1 plus k, and the asymptote is y equals to k. Now, when you have y equals to log base b and the input x minus h plus k, then you exchange x and y to have this new notation, right? So key point, you need to exchange x and y. So 1 plus k become 1 plus h. And the h become k. When you exchange x and y, also you change h and k, right? And the asymptote, you exchange x and y, so y become x and the k become h. So this is a formula, and then we can try the new formula with different parent graph, which is equals to 1/3. Okay, so here we have h equals to -5, k equals to -7, and the base is 1/3. So remember 1/3, the graph, the parent graph, how it looks like, I don't remember. I always start from base is 3, but anyway, let me double check for you. 1/3 is this one, right? This one. So let me remember this one, and that goes to 1/3. So our parent graph and 1, 0, and looks like that. Right? Okay. And then we have new key point. So our key point is 1 plus h, right? So 1 plus h, and then k, which is -4, -7. And the asymptote is x equals to h, -5. Okay, so this is x equal to h, and this 1 plus k, 1 plus h, and the k. So this is the new formula. Okay. Now the new -4, -7. 1, 2, 3, 4. -4, -7. 1, 2, 3, 4, 5, 6, 7. -7. -4, -7. And then our new asymptote is -5 here. X equal to -5. And the key point is here. So we can pretend this is, so it's dropped down, right? So this line, this x-axis, there's a new x-axis. Basically, you can have new x-axis drop down. So you can 1 down and 1 up here. Then we are done. Okay. Now domain and the range, you can depends on the graph. You can find the domain. Domain in this case looks like a x. X need to be greater than -4. And for the y value, keep going down, keep going up. So the range is, you can say -infinity to the positive infinity, or you say all real number. And then for this one, domain x need to be greater than this number, which is 5. X greater than 5 for this case, right? Everything greater than 5. And for the y value, keep going down, keep going up. So the range is -infinity to positive infinity, or you say all real number. So I'm done with the third video for talking about the domain and the range and the graph of the logarithmic function.